Law of definite composition. Compounds always contain the same elements in a constant proportion by mass. Look at water. Water is always 11.19% hydrogen and 88.81% oxygen by mass, no matter where it came from. Okay? Water is water. Ethanol always has the same composition. So really, if you're looking at vitamins, right, and you can get synthetic vitamins that were made in a lab or ones that were extracted from plants, the actual vitamin, the compound, is exactly the same. There is no difference. Now, some of those might have some other things that came along with it. Those could be different. So I'm not saying that, natural vitamins are necessarily a complete waste of money. There may be other compounds in there that are beneficial to you. But the vitamin C that you make versus the vitamin C that you extract from something like rose hips or something, exactly the same compound. Law of definite composition. Chemical formulas help us to describe compounds. A molecule is a particle that's composed of two or more nonmetal atoms. So here's an example of a molecule. And we use chemical formulas as a shorthand to abbreviate what's in the molecule. It tells us the number of atoms of each element. So for this molecule, the formula is H2SO4. The H tells us hydrogen, and the 2 after it as a subscript tells us there are 2 hydrogen atoms. There is 1 sulfur atom. Chemists have a thing about the number 1. We don't write S1 because, we're lazy, or maybe we're just really efficient. We don't need the 1. If there wasn't at least 1 sulfur, we wouldn't write the S, right? So just the S, no 1. And you'll see that as a pattern, we often leave 1s out. And O4, 4 oxygen atoms. So we look at this chemical formula and we can tell what's in the molecule. So when we write chemical formulas, we give the number of each type of atom as a subscript. And if there's only 1, we don't write the number 1. So the vitamin niacin has 6 carbon atoms, 6 hydrogens, 2 nitrogen atoms, and 1 oxygen atom. What's the chemical formula? What's the symbol for carbon? C. And so then we'll put 6, because there's 6 of them. H6. Hydrogen is H, and there's 6 of them. Nitrogen is N, so 2. And then 1 oxygen, so we'll just put an O at the end, and we won't put the number 1. Okay? Writing a chemical formula. Some chemical formulas use parentheses to make it more clear what the atomic composition is. This is ethylene glycol, which is a component of many antifreezes. So if we look at this formula, C2H4OH2, the parentheses are like parentheses in math. This 2 on the outside would be distributed across everything inside. So this tells us 2 OH groups. So 2 oxygen atoms and 2 hydrogen atoms, 2 units of OH, each unit having 1 oxygen and 1 hydrogen. So you take this and you multiply everything inside. If it had a subscript, you would multiply the subscript. So altogether, this molecule has 2 carbon atoms, 4 hydrogen atoms here, and 2 more over there. So a total of 6 hydrogen atoms and a total of 2 oxygen atoms. But we write it out this way because that gives us a better idea of what the structure is.